us to solve this equation, 5 times cos x plus 2 equals 1. Now compare this with normal algebraic equations like just 5x plus 2 equals 1. We would subtract 2 from both sides and then divide both sides by 5. Well, that's a perfectly valid approach to starting this equation. Let's take away 2 from both sides and let's divide both sides by 5. Now 1/5 is 2/10, so we're asking what angle has a cosine that's negative 2/10, negative 0.2. So first off, let's look at the cosine graph. There it is. Maybe I should wipe out this. Here's a cosine graph. Negative 0.2 will be down about there. And you can see that we're going to get a value between 90 and 180, that's the second quadrant, and another value between 180 and 270. There's a couple of values going on. You could figure this out, of course, by using your quadrant diagram and all sine tan cos, where we're saying where is the angle, which quadrant is the angle in for the cosine to be negative. Well, all three sine, cos and tan, all three of them are positive in the first quadrant. Only the sine's positive in the second one, so certainly the cosine's negative in there. Only the tangent's positive in the third quadrant, so certainly in there also. And the cosine's positive in the fourth quadrant, so it can't be there. So as we've figured out from this graph, the second and the third quadrants, second and third quadrants are what we're after. Now the first thing to do is to state that. We'll say x is in second or third quadrants. And let's try and figure out, suppose it was just the cosine of x being 0.2. Suppose it was up here. And it was a straightforward first quadrant angle. So the first quadrant angle, and we would get this by asking what angle has a cosine that's 0.2? Now in my calculator it's this button here. On yours it may well be cos to the minus 1. This is arc cos. This it does the same. Make sure that you're working in degrees on your calculator, that your calculator's in degree mode, and we'll say what angle has a cosine that's 0.2. That's what you do in my calculator, but as I said, it might be cos to the minus 1, 0.2 on yours. And if it was just first quadrant angle, we would get 78.46 and so on. Let's put that away now. So we'd say it's an angle somewhere there, 78.46. However, there are other positions. This is sometimes called the butterfly diagram. An angle in the second quadrant, we'd go all the way around to 180 and then subtract that first quadrant angle. So to get the angle in here, it'd be 180 minus. To get the third quadrant angle, we go all the way around to 180 and add this first quadrant angle. So it'd be 180 plus. Now that's all we're going to need now, that x is equal to 180 minus 78.46 degrees, or 180 plus 78.46 degrees. So that's your second quadrant angle, that's your third quadrant angle. So let's go back to the calculator and let's do 180 minus that first quadrant angle. Now that gives us 101.53 and so on. We'll round it off in a minute. Or 180 plus this angle. So that gives us 258.46 and so on degrees. So let's approximate these solutions to one decimal place. That's usually what we do with degrees, with angle sizes. So that would be 101.5 or 258.4. Chopping a 6 off, that becomes 5. It's nearer to 258.5 than it is to 258.4. So x is approximately equal to these. Or solving this equation, we would probably not put the degree sign in and just say x is 101.5 or 258.5. But we'd have to declare what accuracy, and that's to one decimal place. Declare what accuracy we're making it. That's Mr. Corsi signing out. Hope you enjoyed the video.